So in our previous video, we have discussed what a transformation is Spark and did a deep discussion over narrow transformation. We saw how narrow transformation work and saw example for select, filter, and see the query plan created by Spark for us. We also discussed the theory of wide transformation into the action in continuation to that next video. Hello to world, welcome back to another video. So this is the continuation of our last video, that is the transformation. As we have already seen the narrow transformation and I have discussed you what the wide transformations are in the theoretical aspect. Now let's directly jump into our Databricks environment. Okay. So till our video, we have seen how the query performance was working. Okay. Now let's put down the heading for our wide transformation as well. And I will be putting it as a heading to wide transformation. Okay. Control enter. So let's write the code for it. Okay. Let's say I want to, create a reason wise sales. Okay. So what I can do is I can do first I have to select the reason, right, for this. So df dot what I will do. I want to group it. I want to group it on the basis of my reason. That is my reason. I have selected the reason. Okay. Now what I want to do, I want to get the sales for that. So I want to aggregate it. Okay. I want to aggregate it. And in aggregate, what I want to do, I want to do the sum of what I want to do. Sum of what? I want to do sum of my sales, basically. What is that? That is my sales amount. That is my sales amount column. Okay. By the way, this column is you can check it if you are not familiar with the data. You can check it here. There's a sales column. Where is our sales column? Come in front of us. Sales channel. What is the discount customer type? Unit cost, product shows sales amount. This is the sales amount. So basically, what we are trying to do is, if I see, right, this is the east data. So I'm trying to sum the sales amount where the region is east. So basically, I will know in east region what is the sales going on. Okay, this is what I am trying to achieve. This is the pain point. Now you can give the alias for it, like similar to SQL, alias, as what you are trying to make it is. So total sales. I want to represent as total sales. Okay. And now I want to make it as df underscore reason sales. Okay. Make sense? Now I will print it. Actually equal to should be here. That's what I was thinking why it is giving error. Display my what? Df region sales. I want to display this. Just keep it here. Okay. Now just run it. And definitely it is going to give us we have already predicted the output, right? But we are not interested in the output right now. We are interested in the wide and narrow transformation, right? So let's go to the query profiling and see what it has done. Okay. Now coming to the query profile, what it has done from the very initial, it has scanned the table. It has taken around 1000 of rows and it has converted it into the columnar for faster. What is that? And then it has group aggregate on the reason. Okay. So it has done the aggregation. It has done on the aggregation and it has done the shuffle. This shuffle is the expensive transformation which I was discussing to you. After that, just keep this thing in mind. Okay, just keep this thing in mind. We were doing shuffling here. We don't do. Spark has done this for us. We will see the query profiling again of narrow transformation. This shuffling will be missing from there. Okay, and again after shuffle, it has done the aggregation. Okay, just see the pattern. 1K record were scanned. Out of that, 4 rows were taken out. On those 4 rows, what would be the output? These output will be the region east, west, north, south. After that, east, west, north, south shuffle, it has done the aggregation on the region. That is summation. Now, after summation, 4 rows came into the picture and result query has chases the four rows to us. So that is why we are seeing the 4 rows here. Okay. That is how Spark has optimized it. By default, if you are doing any group type, 200 partitions are created. And I will suggest you, if you have, if you are working over a Databricks environment for any client, or if you have a paid version of it, just go and see the tag of it, because I can't show you the tag in the free edition. So you will see it has, it has shuffled and it has created 200 partitions behind the scenes. That is the thing. group by usually create 200 partition behind the scene, and this is an interview question as well. So this is how it works. Now coming back to our narrow transformation, just see the query profiling here. It was very straightforward. It has just done the filter on that particular partition and it has resulted in the output. That's it. No shuffle was done here. If there will be multiple partition, it will apply the same partition to different things. Okay, so this is how our wide transformation are different from narrow transformation. Let's do some other activity as well. Let's join something. Okay, I want to show you the join as well. Let's join. What we can do. Let's filter first. Okay, let's filter some based on the date. Okay, so what I want to filter is I want to filter on basically my columns. Okay, so I want to filter on column and on the sales date. What is that? Will be the sales date. And the sales date should be greater than equal to starting from let's suppose 2023, 2020. What is that? 01? What is that? 01. That is, we are taking sales from January 01 and till where we will go. Let's suppose we will go till March. Okay, so let me copy paste this again. This thing. What is that? Okay, and what is that? A copy paste and condition, and let me paste this again. And we want data now which should be less than equal to March. So I will convert the sign less than, and that will be March 31 days, right? And month will be March. Okay, so I am taking the one data from January to March. Okay, and let's name it as well. Equal to, I want to name it as df underscore Jan to March, MARCH. Okay, and let's copy this again. Why we are doing filter, because I want to show you a kind of join, how join is getting performed over here. Okay, and March, let's take it from April to, let's suppose, September. What is that? 80. Okay, we will just change the dates here. Month, that is April, is 4th month and it is 7th month. Correct? It is 7th month. So we have September goes till 30, right? September goes till 30. Yeah, it goes till 30. So let's join it. So df join, I will result into here. What I will do is df underscore Jan March dot join. I want to join this with my df April dataset. That is this dataset. Okay, I want to join it. Let's see the query profiling for that. And in the join, you have to specify like what is that you are trying to join with. Definitely, like you have to give the key. So I want to join based on the product key. Okay, product ID basically. So product ID is a column for us, and I want to join it. If you want to join on multiple, multiple columns, so you can just give the column next to it. Likewise, and keep this in practice. Just start giving this. Some people usually there is one key, no need of this array. No, that is not the good thing. Actually, that is not a good approach as well. Okay, so just keep in your habit. Now I will do display df join. Has taken multiple thing here. I don't need all this. I just want to display this. Let's see the query execution for this. It will basically, what it will do, right? It will scan the two tables and it will bring down into a one tree of kind of thing. So let's see the performance here. And in the df join performance, what we are doing, let's see that. Okay, coming to the very below. Okay, first of all, let's check this one. This is from January to March. Okay, so this one is the January to March column, and this one is our April to September. Okay, so what it has done is, from first of all, it has scanned around 312 rows. Okay, and then on this row to column, it is something again the big data thing. It is converting it to columnar format for faster retrieval. Then it has performed the filter. Same way goes here as well. See, same ways go here as well. Now it has to perform the join. So joining key has to be in the same partition, right? It has to be in the same partition. That's why you can perform the join. Let's suppose there are 3 partitions. So joining key for this and this partitions reside into the same. So What is that joining key? My joining key was, let me open that. I can open it. Can I? No, I am not able to. Okay, so my joining key was product ID basically, if you doesn't remember. So what it has done during this shuffle, it has bring the product ID to same partition. What is that? And it has done the inner join. Okay, product ID on product ID and product ID. So product ID came into the same, and after that it has limited the row and it has given us the query result like this. So join is also a kind of byte transformation. Wherever shuffling is being done, everywhere it is a white transformation. Hopefully you might have understand how much important the white transformations are and why they are sometimes important, how they also even work. And we have gone an extra mile of learning how join works as well, right? So hopefully you would have liked the video. If you have liked the video, please drop your lovely comments below and like the video. And after liking the video, there is a hype button. If you will press that, definitely it will help me to grow as a content creation of data engineering in Databricks environment. So that will be very grateful of you. Okay. Thank you. See you in the next video. What is that?